Hello everyone, welcome to Almighty Tricks. We are going to solve one question from LeetCode single number 2. Similar question you can find it in InterviewBit and GeeksforGeeks, and it is one of the question from the single number series. So we already solved one question related to single number. So I'll put a link in the description. Okay. So this question basically it is saying one array is given. So in that array, every element appears three times, okay, except one. So we need to find that exactly one appear number, okay. So here also it is saying you must implement a solution with a linear runtime complexity and use only constant extra space. So it is saying we need to implement it in big of n time and with constant space. Okay. So the array it given like this. We can have 3 2 and 1 3. Okay. So the output will be 3. Similarly, if you see here, there are three zeros, the three ones, but single 99. So our output should be 99. Okay. And constants are like you can see 3 into 10 to the 4, the length of the array. It can be, and it is saying three exactly three times a number can appear, and only one number will appear once. So we need to find that. Okay. So let's get into the notepad. So we can solve this question in different ways. So one of the way we can the approach one can be like this. So let's say we have number 3 3 3 7 7 7 1 1. So if you see this is our input array, let's say input array, this is the input array. So our output should be 11, right? Because 3 times 3 is there, 3 times 7 is there, but only once 11 is there. So output should be 11. Okay. So the first approach I can think of like I can use hash map concept, okay, or hashing concept, that is like key and value pair, okay. Key and value pair. So what I'll do in the key, we can have the array of I means it is the array element and the frequency, how many times it is present in the array, okay, frequency, the value. Okay, so what I mean, so if I prepare this one, so this frequency map will be looked like this. So 3 is coming 3 times, 7 is coming 3 times, and 11 is coming 1 time. Okay, so now I'll take this variable. Let's say this is map variable. Okay, so I'll take this for loop map. Okay, if value equals to 1, then I'll return the key, return that. So this is the simple one. Okay, but if you see here, the time complexity we are using big of n. Okay, so which is asked, so linear time complexity we need to use, but the space complexity we are using big of n space, because we are using map, right? This hash map we are using, so it is taking big of n time, but it is asked for constant space. Okay, but it is taking big of n space. Okay, so let's check how we can solve this. Okay, before going to the approach 2, we just need to understand some properties of bit manipulation. Okay, so let's say I have A and B. Okay, I need to find a jar of A and B. Okay, so let's say edge 0 0 1 1 0 1 0 1, right? So jar of A and B will be 0 1 1 0, right? This is one property. Another property, let's say there is a question like um, uh, find ith bit is set or unset. Set or unset means 1 or 0, right? So let's say one number n is like 2, right? So we can represent in binary like this 0 1 0, right? So this is the first bit, second bit, third bit. Okay, so let's say I want to check this first bit is set or unset, 1 or 0, right? So for this we know one formula, like we can do like this, and one left it of I means which bit. Okay, let's check this. So it means also 2 to the power I. Okay, it means also 2 to the power I. Okay, so I want to find this bit 1. Okay, so 2 to the power 1 means what? 2 to the power 1 means it's 2. Now, so 2 and 2. Okay, 1 0 0 1 0. Okay, if I take end of this, so it will be 0 1 0. So this is 1, right? We are getting 1. So this is set bit. Okay, this is another property. Okay, this is another property. Now uh, now get into the solution. Okay, so let's say I have array. This is my array. Okay, 3 3 3 7 7 7, then 11. Okay, can I write let me write in binary form. So 3 we can represent like this, right? 0 0 1 1, right? So 3 threes are there, so 0 0 1 1 0 0 1 1, right? The 7 we can represent like this: 0 1 1 1 0 1 1 1 0 1 1 1. Okay, so we'll take this 11 later. First observe one thing here. Let's say this is my 0th bit, first bit, second bit, third bit. Okay, now if you observe one thing, so in 0th bit, in in 0th bit in 0th bit, how many set bits are there? In 0th bit, how many set bits are there? 6, right? 1 1 2 3 3 4 5 and 6. Okay, 6 set bits are there. In first bit, how many set bits are there? 1 2 3 4 5 6. 6 bits are there. Okay, in second bit, how many set bits are there? 1 2 3, right? And in third bit, how many set bits are there? No set bits are there, so it is 0. Okay, now take 11, represent this 11 in binary form. So how can we represent 11 in binary form? That will be like 1 0 1 1, right? 1 0 1 1. Okay, now observe another thing. So after having 11 here, okay, after having 11 here, so now how many set bits are there for 0th bit? So previously it was 6, right? Previously it was 6. Now I have added another one, so it is become 7, right? 7 set bits are there in 0th bit. Similarly, in first bit we have 7, but if you see this one, we are adding 0. We are not adding set bit. We are not adding 1. So it is 3. The total set bits are as it is. Okay, 3. And here also we are adding 1, so it will be 1. Okay, so if you observe one thing, before adding 11, before analyzing this 11, so here basically it is multiple of 3, right? This 3 is multiple of 3 into 1. This 6 is multiple of 3 into 2, and similarly this is also multiple of 3 into 2. Okay, but when we add this 11, that time it is changing, so it is not multiple of 3, it is not multiple of 3, but it is multiple of 3 because we are not adding anything. Okay, it is not multiple of 3. So we try to use this concept in the code by which we can solve this question. So let's code this one, then I'll dry run with this example. Okay, so let's code this. So I can have let's say I can have int answer. Okay, and I'll take for loop. So here basically we are taking bit by bit. We are checking bit by bit. So let me take bit is 32. Integer bit is 32. Okay. So what I'll do? My I will go from 0 to 31. Right. Now I'll take for loop. For loop. Here basically in the J, it will check it will take each and every element, and it will check the bit for each number. Okay, so here actually I need to loop through the array. Sorry, loop through the array. So it will go 0 to n minus 1. Okay, the array. Okay, now what we are going to do? What we are going to do? We need to have one counter which will check this number, how many set bits are there, okay, for each and every bits. Okay, so here I need to have one counter, int count. Okay, now if you see here, so in the initially I have explained how we can check the bit is set or unset, okay, using this formula. Okay, let me write this. So here basically I need to check that uh, particular bit is set or not. Okay, so I can write a of j. This is for uh, array, right? This is for array, this is for bits. Okay, if array of j and one right shift of I. Okay, I means what? This is the I. Okay, is not equals to 0. If it is not equals to 0, okay, it means what? It is set bit. Then I will increase the count plus plus. Okay, then I will close this for loop also. Okay, now another now what I need to do? I need to check whether this number can be divisible by 3 or not. Okay, divisible by 3 or not, these numbers. Okay, if it is not divisible by 3, because if it is not divisible by 3, it means what? It is in this location it will have 0. So we no need to take care of this thing. We need to check this thing where we have one counter extra after adding this one. Okay, so what I mean here, I need to check if count modulo 3 equals to 0. Sorry, not equals to 0. If it is not 0, okay, not divisible by 3, then what I can do? My answer will be answer equals to what I can do? I'll convert. I'll right shift I times. Okay, I'll right shift I times. So for loop is closed, then I'll return answer. Okay, so this means, and so you know this means 2 to the power I, right? This is also 2 to the power I. This is also 2 to the power I. Okay. So this is the normal, very easy solution. So let's try run this. How we can solve, means how it is working. We need to check this. Our I is 0, right? This I is 0. Then j is what? J is also 0. Okay. Then count is what? Count is also 0. Okay, then answer also 0. Okay, all at 0. Now our array, what is the array? This is our array, right? This one. this one is the array. So let me write here. So array is 3 3 3 7 7 7 1 1. Okay, so 0 0 0 1 2 3 4 5 6, right? You can write like this. Now start with this. So here my I is equal to 0. I is initially 0, then it will come here j is equals to 0. J equals to 0 means what? It is targeting this element 3. Okay, so this is targeting 3. Okay, now if you see a of j 3 and of 2 to the power I, 2 to the I means what? 2 to the power 0 0. Okay, this is because I is 0 initially. It means what? It is like so it means what? It is checking for this bit. We are now checking for this bit. How many set bits are there? Okay, so if I do this one, so 1 0 0 1 1. Okay, 2 to the 0 means what? This is 1. So 0 0 0 1. So if I do AND, then it will become 1 0 0 0. Okay, so it is becoming 1. So it is satisfying. Okay, so count is become 1 now. Count is become 1 now. Then j also become, it is satisfying. Then it will come here. So j also increment. J is become 1. Okay, now j of 1 means 3, right? So now same thing will happen, like 0 1 0 0 1 1 and 0 0 1. Okay, same thing will happen. So it will increment to, so it will increment to 2. Count will 2. It will become what? It will become 2, right? It will become 2. So now we'll check a of index 2 is same 3. So it will become 3. Then it will become 3. Okay, index and j of 3 means what? J of 3 means 7. So we'll check for the 7. Then means what? 0 1 1 1. Okay, and 0 0 0 1. If I take the end, then it will become 1, other thing will be 0. So it is 1, so it will count, increment the count. So count will be now what? When j is 3, that time count will be 4. J increment to 4. Okay, j increment to 4, right? Now in the a of 4 means what? 7. Same thing, it will count, increment to 5, and j will increment to 5. In j of 5 it is present 7. Again it will increment to 6. Then j will increment to 6. But if you see um, j of 6 has 11. Okay, j of 6 has 11. Okay, let me check that one. So for 11, how we can write 1 0 1 1, right? Then end with 0 0 1, sorry, 0 1. Okay, so it will become 1 0 0 0. Okay, yeah, it is satisfying. So we will increment the count. Then when j is 6, so it will become 7. Okay, so for ith bit is I for this bit is we are getting count 7, right? So it will come here. Okay, so it will check count modulo 3 is not equals to 0. Correct, 7 cannot be modulo of, okay, so 7 divided by 3, the remainder will not be 0, right? So what it will do, the answer will be, so we need to do 2 to the power I. So answer plus 2 to the I. 2 to the I means what? 0 0 0 1. So it will add. Okay, so it will become 1 0 0 0, right? Now this part is over. Now it will increment the bit. Okay, so it will come to this bit. It will come to this bit. Okay, bit number 2, bit number 1, sorry. It will come to bit number 1. Okay, so for bit number 1, so now I will increment to 1, right? I will increment to 1, j will be 0, count will be 0. Okay, so it is increment to 1, then count will 0 again, j will 0 again. Okay, but answer will be 1 as it is. Okay, so here again it will check for for a of 0. A of 0 means what? 3, but and 2 to the I means what? Currently I is 1, so it will become 2, right? 2 to the I means what? 2 to the 1, it will become 2. Okay, 2 we can represent 0 0 1 0, right? Now a of j means what? 3, so 3 we can write like this: 0 0 1 1 0 0 1 0. If I take and, then here becomes 0 1 0 0. Okay, we are getting, it is satisfying this condition, so count will increment to 1. So count will increment to 1 and j will increment to 1. Okay, so a of 1 what? 3, so same thing, count will increment to 2, j will increment to 2. So what I will do, answer is previously this one, now I'll add with 0 0 1 0, so it will become 1 1 0 0, right? Now now this thing is over, now it will come here, so it will increment to uh, what? It will increment to 2. So we solve this, we solve this one also. Okay, now we go to second bit, third bit. Okay, so we can write 2 to the, for this I left shift of I, 1 left shift of I, so we can write 2 to the power 2, right? So it will become 4, so we can write like this in binary form: 0 1 0 0. Okay, now a of j means what? 3. That 6 is divisible by 3 and its remainder is 0. Yes, it is correct. It is giving remainder is 0, but it is not satisfying. Okay, so it will, what it will do, it means it is 0, right? So it will add with 0 0 0 0. The answer will add with 0. Okay, now it will become, now it will become 1 1 0 0. Okay, now same thing. Now it is, this loop is over. Now I will increment to 3. I will increment to 3. Okay, so when I is increment to 3, so we will be focusing into last bit. This one we will focusing into last bit. Okay, so I, when I is 3, okay, so j is also 0, count is also 0, and this one will become 2 to the power 3. This one will become 2 to the power 3 is 8. We can represent 8 as like this: 1 0 0 0. Okay, so a of 3, a of 0 means what? 3, so 0 0. To the I means 8, so 1 0 0 0, so 1 0 1 1, so it means what? 11, right? We are getting the answer. So this is taking time complexity as a big O of n, linear time complexity, and space complexity as big O of 1, constant time complexity. Hope you understood this one. Let's code this one. First of all, we need to have int size of array, nums dot length. Okay. We need to have answer, int answer equals to 0 initially. We'll return this answer. Now we'll take for loop for the bits to 32 bits. Int I is equal to 0, I less than 32, I plus plus. Okay. Then here I need to take count, int count equals to 0 to check the number of set bits for the particular bit. Okay. Now for loop will loop through the array. int int I equals to 0, sorry, j equals to 0, j less than n, j plus plus. Okay, now I need to check the condition if this particular numbers, this particular bit is set or not. So what I'll do, I'll take a of, sorry, nums of I and operator 1 left shift of I is not equals to 0, then I'll increment the count, right? Then after this for loop, I need to check whether this count is divisible by 3 or not. Count modulo 3 is not equals to 0, then I'll add the answer. Okay, with 1 left shift of I, nothing but 2 to the power I. Okay, then I return answer. Let's check this code. Okay, we are getting some errors. Okay, so it is should be 0, so it should be j. Okay, submit. Okay, so hope you understood this approach. So it is taking big of n time and space complexity as a constant. Okay, thank you for watching this video. See you in next lecture.